Hello everyone, I'm Dewan Saiful. I'm honored to presenting our research work titled a CNN-driven deep learning model for accurate stage detection in medical imaging to enhance stroke diagnosis. And this work actually contributed in collaboration with Mr. Ekramul Hasan, Dipta, MD Amin, MD Tuhin, and Mustafizur Rahaman. So let's jump on our overview of our research work. CNN-based framework for early stage detection and classification using brain CT image. The baseline model, we achieved 96.8% accuracy, where the recall was 0.95. Precision was 0.98 and F1 score was 0.97. We are proposing an enhanced model also, where we achieved 98.4% of accuracy, and this system is level and optimized for both clinical and remote setting for medical purposes. We all know that we are living in the era of AI, where AI is a blessing for humankind. So AI and machine learning, the transforming the medical images and making the decision for the medical experts like a doctor and radiologist or other stuff. So we all know that stroke are the major cases for early death and disability all over the world. So our main focus for this research work to detect different type of strokes, and the goal was to propose a efficient CNN model which can predict accurately the stroke images from the diagnosis, and it's also be a low computational cost. So here's the research motivation for us. Why we chose this research. There is a global shortage of expert radiologists over the world. So I think that our model will help the expert person to provide the accurate treatment for the patients come affected in the stroke. So the traditional or existing SVM or random forest approaches are minimal feature engineering, which is not as good as the CNN enabled automated feature extraction. So it also improves the diagnosis precision and accessibility. So it will provide the improving both precision and accessibility, providing the better diagnosis and detecting the stroke affected images from the CT medical images. So let's jump on the research methodology. So we actually use the publicly available CT images dataset from Kaggle, where we do the pre-processing or data pre-processing based on our model. So we resize it to 224 by 224 pixel, and we also keep those images on NumPy arrays, and train and test splits our dataset so that we can train our model, and keep the split part so that we can test it, getting the result from the model. Our proposed CNN model actually follows the convolution layer, polling layer, dense layer, dropout, and the sigma activation layer. And during the implementation, we use the Kaggle GPU resource to properly run our data set and train our model. So here is the architecture of our improved CNN model, where I already explained that we do the image processing related to our database, and after that we train our model. There are few layers for our CNN model. First, the convolution layer, pooling layer, dense layer, and dropout and sigmoid activation layer. So our model actually increased the dropout 0.5 and best normalization also on our model. And training optimization, we use the Adam optimizer, and learning rate is 0.005, and we train our model over 50 epochs. So let's see the evaluation of our model. Here the evaluation metrics we go through for our model, and we follow the accuracy, precision, recall, and F1 scores, the well known and widely used to evaluate the CNN model. And we also assess our model, the mean square error and root mean square error for assessment of our model. And we used the confusion matrix, where the true positive was 62 and false positive was 2 and false negative was 0 and true negative was 62. It's an excellent result, I should say, for our proposed model compared to the baseline model. Here is the comparison result for our proposed model, where baseline CNN accuracy was 96.8%, and improved CNN model is provide us 98.4%. Where F1 score was 0.994 for classification. So we can say that our model actually outperformed than the LateNet and custom CNN model. So in the conclusion of our research work, I should say the lightweight CNN model achieved almost 99% accuracy to detect the stroke based on our dataset. And so it's a streamlined architecture which actually making the real-time clinical application. So the system will enable the fast, reliable, and automated stroke diagnosis, ultimately better decision making in healthcare. So thank you everyone for your attention, and we are grateful to IEEE 2025 and IEEE region team for this great opportunity.